This is the first section of chapter 7 on the simplex algorithm, and this section is formulating linear programming problems. Now, in the previous chapter, we looked at linear programming problems where we had two variables and they would have been, or we would have used x and y, and we could solve these problems because we could actually draw the sort of graph on a grid like this, because we've just got two axes, x and y, so that was straightforward to do, because we had two variables. But when we've got more than two variables, then we can't use this method. If you've got three variables, well, we don't really want to draw a 3D sort of inequalities and have them shaded, or 4D or so on. So when we've got more than two variables, we need a different approach. So if we have three variables, for example, we just may use the letters x, y, and z for our variables. Or if we've got more than that, we may label our variables as xa, xb, xc, xd, and so on, if we've got quite a few different variables. So we would formulate our problem, we would write our inequalities either using x, y, and z, or something like xa, xb, xc, and so on. Now, because we've got more than two variables, it may be helpful to actually, when we're starting to formulate our problem, to use a table to write our information and values down. Then the other thing that we need to do is, and we've done this before when we did linear programming, is that we turned our inequalities into equations so that we could draw these lines and then shade the region. We need to do something similar here. We need to turn inequalities into equations, and the way that we turn an inequality into an equation is by adding in something called a slack variable. By adding in a slack variable, that basically means writing down the equation and then you put maybe plus s, plus r, plus t. So usually when we have slack variables, we might use the letters r, s, t, for example, or we might write the slack variables as s1, s2, s3, and so on. And what that does is that turns an inequality into an equation. Just going back to this point here, we may have instead x1, x2, x3. So there's sort of different ways of writing down our variables. We just need to be used to the different types. Example 1. So lots of information here. I'm not going to read through all of it, but basically you've got somebody who can plant 4 different varieties of flower in their field. They take time to sow, thin, pick, and pack, and it's different for each variety. We've got here some information about how much time they can spend sowing, thinning, and picking and packing. And also here it tells us how their total profit is made up for the different varieties, and a constraint here, another constraint here about the amount of land they actually have, and they wish to maximize their profit. So all we're going to do, first of all, is to summarize this information in a table, because it's quite difficult to actually pick out what we want when it's just all in sentence form like that. So the first thing I'm going to do is to write down the varieties of flour and the different processes. So starting with variety A, we have 3, 18, 20, 24. So I'll probably tick these things off as I do the information. Variety B, 4, 17, 25, 27. So I can tick that off. C, 3, 19, 26, 28. So that can be ticked off. And D is 5, 16, 22, 23. And again, that can be ticked off. Now, the next sentence is about the amount of time they can devote to sowing, thinning, picking and packing. Okay, so maybe in this column here I'll write down the time available that they have. So time available. So for sowing they have up to 70 hours. For thinning up to 360 hours, 500 for picking and 550 for packing. So we'll tick off that sentence. Whoops, that one there. Then we'll move on to the next one. And this is about the total profit for each per hectare for each variety. So I'll put here is the heading, profit per hectare. So for variety A, the profit per hectare, it says, is 67 and 63 for variety B, 71 for C, 75 for D. Okay, so that's as much information as I can put into the table. I can't really put this information into the table, but this is going to make it much easier now to actually write down my constraints and the objective function. So the first thing that I need to do is to define my variables. What are they going to stand for? Right, so let's say I've got variety A. I'm going to use X sub A. Variety B is X sub B. Variety C, I think you can see where this is going, X sub C. And variety D is going to be X sub D. Right, so now let's start with our constraints, and let's start with the sowing constraint. So I'll just write down sowing here. So what have we got? We've got 3 hours per hectare for sowing A, variety A. So 3x sub A plus 4x sub B plus 3x sub C plus 5x sub D. And we've got up to 70 hours for sowing. So the amount of sowing has got to be less than or equal to 70. Next we'll look at thinning the flowers. So what have we got? We've got 18 hours per hectare for A, 17 for B, 19 for C, and 16 for D. You can see that actually putting it in the table made it much easier, and we've got up to 360 hours for our thinning. Right, next one we have is picking. So for picking, what do we have? 20 x sub A plus 25 x sub B plus 26 x sub C plus 23 x sub D, and we've got up to 500 hours available. Then packing. So packing here, what have we got? We've got 24 for variety A, 27 for variety B, 28 for variety C, 23 for variety D. So that means actually when I did the previous one here, I was looking at the wrong line. So it's 20, 25, 26, that should be 22. So let's correct that and put 22 in. And that's got to be less than or equal to 550. Now what else have we got? So we didn't put this in the table, did we? So we need to talk about this. He has up to 20 hectares available to use for his crop. So the amount of the varieties that we plant, the total amount of the varieties, can be no more than 20. So less than or equal to 20. Non-negativity as well. We can't have a negative number of flowers. So we need to state that all of our variables need to be positive. Then the last thing we're going to do is to write down the objective function. Now this is about maximizing profit. So we want to maximize P equal to, and to find out what it's equal to, we now look at this. How are the profits made? And actually the bottom of the table here. So 67 for A, 63 for B, 71 for C, and 75 for variety D. Example 2. In order to supplement his diet, Andy wishes to take some Vitatab, Weldo, Extramin, and Vestivit tablets. Amongst other ingredients, the contents of vitamins A, B, C, and iron in milligrams per tablet are shown in the table. So we've got a table here which we can use. Andy wishes to take tablets to provide him with at least, let's underline this, 80, 30, 60, and 14 milligrams of vitamins A, B, C, and iron per day. Because of other factors, Andy wants at least 25% of the tablets to be Vitatab, and he wants to take at least twice as many Weldo as Vestivit. The cost of the tablets are 4, 6, 12, and 7 pence per tablet. Andy wishes to minimize the cost, so let's underline that rather than cross it out. Minimize his cost. Formulate this as a linear programming problem, define your variables, stating your objective, and writing your constraints as inequalities. Right, let's start by defining our variables. Defining variables. Now, when we do this, I could use x1, x2, x3, x4, something like that, or xa, xb, xc, xd. Now, vw, xy, I suppose I could use xv, xw, xx, xy. It's a bit sort of fiddly, so we'll just use x1, x2, x3, and x4 to represent the number of, what are they, Vitatab, Weldo, Extramin, and Vestivit tablets. So what we might want to do is just maybe write at the side of the table here x1, x2, x3, x4. Okay, right, so let's go through the different ingredients. So we'll start with the vitamin A and write down what the constraints are for vitamin A. Right, well, we get 10 milligrams of vitamin A from Vitatab, and we get 15 milligrams of vitamin A from Weldo, 25 from Extramin, and 20 from Vestivit. And what does it say about the amount of vitamin A? It needs to provide him with at least 80, so it needs to be greater than or equal to 80. Right, vitamin B, so it's going to be very similar for vitamin B. So for vitamin B, we're now looking at this column. So 10 milligrams from the first tablet, 20 from the second type of tablet, 15 from the third, and 15 from the fourth type of tablet. And it needs to provide him with at least 30 milligrams, so it needs to be greater than or equal to 30. Then we'll move on to vitamin C before moving on to the iron. So that's looking at this column here. So 20x1 plus 10x2 plus 15x3 plus 20x4, and we need to get at least 60 milligrams, so greater than or equal to 60. And then lastly the iron, so we get 4 milligrams from the first tablet, 5 from the second, 3 from the third, 2 from the fourth tablet, and it needs to be at least 14 milligrams, so greater than or equal to 14. Right, we're on to this bit of information here about him wanting 25 or at least 25% of the tablets he takes to be VitaTab. So let's think how we're going to write this as an inequality. So he wants the number of VitaTab tablets that he takes, x1, to be at least greater than or more than 25% of the total number of tablets that he takes. Now, often if you say it as a sentence, that helps you write down what the inequality is. So the number of VitaTab tablets that he takes, that's x1, needs to be at least 25% of the total number of tablets that he takes. Now, we could simplify this. We could multiply everything by 4. So then we'll have 4x that side, and we don't need to expand the brackets. And then move everything over to one side. And if we do that, so we'll have 4x here already, then we'll be taking away x, so that'll be 3x1, and then subtract the rest of the x2, x3, x4, so I'll have 3x1 minus x2 minus x3 minus x4, and that will leave us that greater than or equal to 0. So we can rearrange it, get rid of that decimal, by just multiplying both sides by 4, moving everything across. Now we're almost there. The next thing we need to do is to talk about non-negativity. So all of our variables need to be greater than or equal to 0. So we'll just put that down, greater than or equal to 0. Now I'm going to highlight these because we're almost on to the last bit, which is the objective function. So I just want to highlight all our different constraints. So there's a vitamin A1, here's the one for vitamin B, vitamin C, the iron, and this one to do with at least 25% of the tablets being the VitaTab. There are non-negativity. So now let's look at how this person is going to minimize their cost. Right, and we're going to find their costs here. So we'll just write down that the objective function is going to be to minimize their cost, and their cost is 4 pence for x1 or 4x1, plus 6 for x2, plus 12 for x3, plus 7 pence for x4. So we'll just highlight that. So everything that you see highlighted will form your solution for this question. Example 3, what it's asking us to do is to rewrite the inequality here as an equation using the slack variable r. So it's telling us what slack variable to use, and the way that we turn an inequality into an equation is we add in and just put plus the slack variable. So it's just going to be plus r equals 23. That's all we need to do. So to change an inequality into an equation, we add in a slack variable and then we can write equals. Example 4, rewrite the constraints for example 1, which was the first example that we did, as equations, and it tells us what slack variables to use. So all we need to do for each one of these inequalities is write it down, add in the slack variable. Now the first slack variable they're asking us to use is r, so then we can put equals 70. For the second one we'll do the same thing, 17x sub b plus 19x sub c plus 16x sub d plus the slack variable s. Now we can write equals 360, and we'll continue and do the rest. So that's the last two done as well. Now when we come to this, we've got some new variables here and they need to be included in this as well. Our slack variables must also be non-negative. So when we talk about non-negativity, not just the variables that we started with, but slack variables must be positive. So we must declare them or write them down here and state that they also need to be greater than or equal to 0. So you should now be able to do exercise 7a on pages 174 to 175 of the textbook.